right, today we're going to start talking about mean absolute deviation, and that's a really big word that means something pretty simple. So first we're just going to find the mean of a set of data, which is the average. You add together all the values and then divide by how many values you have. That's what we've done for our warm-up yesterday and today. And then we're going to find the mean absolute deviation, which is the differences between each of those values and the mean. And I'll show you what I'm talking about. Why are we calculating this? Because the smaller the mean absolute deviation, the closer the values are to the set of data. So when we looked at our scatter plots and we saw those scatter plots where the data was pretty closely lined up, and I could draw a pretty straight line through it, and we had a strong correlation, mean absolute value will give us the numerical value of that. Or I could have a looser association where my data is more widely spread out, but I still see that I have like a positive linear association or a negative linear association. So let's look at an actual chart and see what we're talking about. So here I've been given a data set. So I have 10, 18, 20, 13, 17, and 18. So I can find the mean of that data. So step one is just finding the mean, the average of those numbers. So in my calculator, since we have graphing calculators, we can add all of those together at once. So I can do 10 plus 18 plus 20, make sure you're doing this with me, plus 13 plus 17 plus 18. And when I add all those together, I get 96. So that's going to go right here. And then I need to divide by how many values I have here. So I have 1, 2, 3, 4, 5, 6 different numbers. So I can leave that 96 there, and I'm just going to hit divide by 6, and it takes my previous answer and divides it by 6. So, divided by 6. So that gives me a mean of 16. So the average of those values is 16. Now to find the distance from the mean, my mean is 16, so I need to figure out what the difference is between 16 and each of these numbers. So the difference between 16 and 10 is 6. And I can subtract. I could do 16 minus 10 on my calculator, and that would give me 6, and I could figure it out that way. I could count up. I could start at 10 and count up till I get to 16. Whatever's easiest for you. It's really going to depend on the numbers that you have. 18 is only 2 away from 16. We can do 16, 17, 18, count up and get 2. 20, so I have 16, 17, 18, 19, 20, so there's only 4. 13 to 16, so I can do 13, 14, 15, 16. That gives me 3. From 16 to 17 is only 1. And then from 16 to 18 is 2. They're only 2 numbers away from each other. So now I'm going to put all these numbers right here to calculate the mean absolute deviation. So I have 6, 2, 4, 3, 1, 2. So I'm going to add all those together. 6 plus 2 plus 4 plus 3 plus 1 plus 2. And hit enter. So the total is 18. Again, I have 1, 2, 3, 4, 5, 6 numbers there, so I'm going to divide by 6. And that gives me a mean absolute deviation of 3. So that means the average distance between my trend line and each of my data points is only 3 points away. Okay? So that tells me that all the data on this chart is pretty close together. It's pretty well associated. So let's try one more. I'm going to clear this out. A group of 7 families on Stephen's baseball team sold magazine subscriptions to raise money for the team. We need to find the mean absolute deviation. So we're going to start by adding all these numbers together. Now I see a bunch of decimal points and zeros, but these are all whole dollar amounts, so I'm not going to add the 0.00 on each one. Let's just add our whole dollar amounts. So I have 64 plus 98 plus 11 plus plus 28 plus 24 plus 13 plus 98. Altogether, I get 336. And then I'm going to divide by how many numbers I have. So 1, 2, 3, 4, 5, 6, 7. So I'm going to put that in my calculator, divide by 7. And that gives me a mean of 48. Now I need to find the mean absolute deviation. This is my mean. This one doesn't give us the chart like we had up here, but I can do it myself by just writing that deviation above each number. So the difference between 64 and 48, I'm going to go ahead and put that in my calculator to make sure I get it right. So I'm going to do 64 minus 48, and that gives me a value of 16. So I'm going to write 16 above that number. I'm going to do the same thing here. 98 minus my mean of 48 gives me a value of 50. Okay, this person only sold 11, so I'm going to do 48 minus 11 to find that difference. That gives me 37. Then I can do 48 minus 28 to find this difference. That gives me 20. 48 minus 24 gives me 24. 48 minus 13 gives me 35. And then my last value is 98. We already did that one here, so I know that that's 50. Now I can total up all of my deviations to find the mean absolute deviation. So I'm going to add all these numbers together. So I have 16 plus 50 plus 37 plus 20 plus 24 plus 35 plus 50. And that gives me a total of 232. I'm going to divide by 1, 2, 3, 4, 5, 6, 7 again. And that gives me a mean absolute deviation of 33, and I'm going to round to the hundredths place, 0.14. So mean absolute deviation, we can call it MAD, is 33.14. So on this data value set, my mean absolute deviation was only 3. On this one, it's 33. So I know if I were to make these two data sets into scatter plots, these dots would be much closer together, and these would be much further apart. Okay. So we're gonna ignore the question for now. Let's look at our guided practice. Because in just a second, you're gonna do an assignment that looks just like this. So look at this second sheet. Here's one more example. Linda was asked to create two data sets so that the following would be true. Set A has a mean larger than set B. The mean absolute deviation of set A is smaller than the mean absolute deviation of set B, and each must contain 5 data points. So let's calculate that and see if she accomplished it. Okay? So each data set has 5 data points, so we know that's correct. Let's find the mean and the mean absolute deviation of each one. So we're going to add all these together. 42 plus 14 plus 34 plus 60 plus 32 equals, so we have 182 divided by 1, 2, 3, 4, 5. And we have 36.4. This is the mean. Okay. And then we need to find the mean absolute deviation. So I'm going to do 42 minus 36.4. That gives me 5.6. Then I have 36.4 minus 14. That gives me 22.4. Then I have 36.4 minus 34. That gives me 2.4. Then 60 minus 36.4 gives me 23.6. And then the last two, we have 36.4 minus 32, and that's 4.4. Now I need to find the mean of this data set. So 5.6 plus 22.4 plus 2.4 plus 23.6 plus 4.4. That gives me 58.4. I know there were 5 numbers there, so I'm going to divide that by 5. And that gives me a mean absolute deviation of 11.68. Okay. Now we need to find the mean and mean absolute deviation of this set. Clear it. We're going to do this one more time, and then we're done. So I have 20 plus 12 plus 60 plus 43 plus 36. That gives me a total of 171. I'm going to divide that by the 5 data points that I have. Divide by 5. And that gives me 34.2. Okay. So let's look back up here. Does set A have a mean larger than set 2? That is true. Or set A is larger than set B. A is larger than B, so that's true. Now let's figure out the mean absolute deviation. So we're going to do some subtracting again. So I have 34.2. I'm going to subtract 20, because that's my first data point. That gives me 14.2. Then I have 34.2 minus 12. So that's 22.2. Then 60 minus 34.2. That gives me 25.8. Looks like that number's larger, so 43 minus 34.2 gives me 8.8. And then 36 minus 34.2, and that gives me 1.8. Okay, so let's add all those together. 14.2 plus 22.2 plus 25.8 plus 8.8 plus 1.8. If we enter that all in, we get 72.8. We have to divide by the 5 data points that we had. So let's take our answer, divide by 5. And that gives us a mean absolute deviation of 14.56. So it looks like the mean absolute deviation is smaller on set A than on set B. Is that what this says? The mean absolute deviation of set A is smaller than set B, so that's true. So let's look at our answer choices. Which statement is correct? The 2 sets meet all the criteria given to her? Yeah, that's true. The 2 sets are not correct because set B has a smaller mean than set A. Well, it does have a smaller mean, but that's what it asks for, right? So we'll cross that out. The 2 sets are not correct because they do not contain enough data points. That's not true. We were able to calculate mean and mean absolute deviation. The 2 sets are not correct because the mean absolute deviation of set A is larger than set B. That is not true. So our correct answer here is A. glue this in, and then you will go to Canvas for your assignment.